All right, so let's take a look at here at problem number 18. It's got four parts to it. Now, this time it's asking me to find the domain. I do not have to find an expression for the formula for this new function f plus g. I can if you want, but it's not necessary. To find the domain of f plus g, then I'm going to find the domain of f and intersect it with the domain of g. And that will be my domain of f plus g. Okay, so we've been finding the domain given an equation now for some time. The domain, the default answer is the domain is a set of all real numbers, that you exclude any values of x that cause division by 0, and you exclude any values of x that cause you to take an even root, like a square root of a negative number. So when we look at this function f to find the domain for f, I do not have a variable in the denominator, so I don't have to worry about division by 0. But I do have a variable that's underneath a radical, so I have to make sure that x plus 8 will always be 0 or positive, that it will never represent a negative number. So if I solve this inequality, I have to make sure that for the domain of f, that all of the values of x are greater than or equal to negative 8. Well, let's take a look at the domain of g. Again, I do not have a variable in a denominator. I do have a variable underneath the square root. So just as before, this expression 2 minus x has to be 0 or positive. It can't represent a negative number because I'm taking the square root of it within the set of real numbers. So if I solve this inequality, remember that when you're solving inequalities, if you multiply both sides or divide both sides by a negative number, you have to flip the direction of this inequality. You have to change the direction of the arrow. So if I multiply both sides by a negative 1, I have to flip that arrow, and I'm saying that x is less than or equal to 2. Now remember that this intersection is the idea of and. So these two things have to be true at the same time. That I need x to be greater than or equal to negative 8, and at the same time less than or equal to 2. So if I think about that on a number line, when we first were doing it, to give you the idea of intersection, I drew this number line separate from this one, and then a third number line intersecting the two. Well, I think you now have probably gotten the idea enough now that this first one, x greater than or equal to negative 8, is shading in this direction, and at the same time now, it has to be less than or equal to 2, so I have to stop at 2 and shade this direction. For both of these to be true, the overlap is all of the numbers that are between negative 8 and positive 2, including those endpoints. So my answer for part A, the domain of this new function, f plus g, is the interval of real numbers from negative 8 to positive 2, including both of those endpoints. So there's my final answer for this part A. When you're adding or subtracting or multiplying any function, the answer in A is going to be the same as the answer in B for any f and g, because to find the domain of this new function, now if I was finding the equation, they would look different, but the domain for each of these is the domain of f intersected with the domain of g, which is what we just did. Okay, so like I say, the domain of this new function, f times g, is the same as our answer in part A, negative 8 to positive 2. All right. Now, what you're kind of hoping for with division, it might even be the same answer for division, but it might not be. All right, so why? Why will it sometimes be the same answer and other times that not be? Well, because the formula, the way that we find the domain of this division, it starts out the same, the domain of f intersected with the domain of g, but you might have to have another restriction. This g is now in the denominator. This f of x divided by g of x is in the denominator. And we have to make sure that there's no value of x that would make g of x equal to 0. All right, so I've already done this work. I already know that was -8 to 2. What I don't know yet is if this additional part is going to change that, because I'm going to have and this part has to be true, and it might end up influencing that. So let's temporarily set g of x equal to 0. Let's find out what value of x would cause the output of g to be 0. So if g of x were to equal 0, which is what I'm trying to avoid, well, g of x is the square root of 2 minus x. If I square both sides, the radical goes away, and 2 minus 2 is 0. Okay, so g evaluated at 2 is going to equal 0. I do not want 2 to be in the domain of this new function f over g, because if x were allowed to be 2, then I'm going to have a 0 in the denominator. So on the left here, 2 was, we allowed 2 to be in the domain when it was just multiplication or addition or even subtraction. But with division, we have to exclude the number 2. So I'm going to have to change my answer here. I've got -8 that is in my domain, but +2 now has to be excluded because it causes division by 0. So the domain for this f divided by g is from -8 to +2, excluding this endpoint +2. So it was just a minor change, but an important change. All right. Let's take a look at D. Well, it's the same idea that we just did in C. When you have two functions and you're building a new function through division, and you're trying to find the domain of this new function, you want to take the domain of f intersected with the domain of g. And the intersect, that's the same, taking the domain of g and intersecting it with the domain of f is the same idea, right? It's commutative. But now, I'm still concerned with the denominator, with division by 0, only this time, my function f is in the denominator. I have to make sure that f of x is never equal to 0. Okay, so we've got our answer for the f intersected with g. We know that that's from -8 to +2. What we don't know yet is that going to change? Is there some value of x that's inside this interval that will cause this to be 0? If it's outside of it, it's not going to change. So we come over here and we temporarily say, well, what input would cause an output of 0? And if f is the square root of x plus 8, square both sides, and we see that if x is equal to -8, that f evaluated at -8 is 0, and we need to avoid that. So we need to take the value -8 and throw it out of the domain. So our answers for A and B included both of these endpoints, and now our answer in D is excluding -8 because f evaluated at -8 is equal to 0, and f is in the denominator, and we never want that denominator equal to 0. Therefore, we don't want to allow x. We do not want to allow x to be equal to -8. So our domain for g divided by f has a parenthesis at -8. So there's my final answer for part D, and I think that's all of 18, isn't it? Yeah. I hope that helps, and I'll talk to you later.